So, in the last classes, we learnt about the basics of TensorFlow 1. TensorFlow 1 basics. We understood why TensorFlow 1 is very important. And let us first go back and understand the difference between TensorFlow 1 versus TensorFlow 2. So TensorFlow 2 is relatively easier for execution, although it is not as easy as Keras, but TensorFlow 2 has a lot of things that make it really easy when compared to TensorFlow 1. Like, remember in TensorFlow 1 we had the graph which we had to run in session. In TensorFlow 2 there is nothing as a session. So that means it has eager execution, which means it can be executed without using the session. This execution is known as eager execution. TensorFlow 2 can easily be integrated with Keras. So you can use Keras while using TensorFlow 2 and vice versa. However, you cannot do that in TensorFlow 1. So these are some of the reasons, but TensorFlow 1 obviously gives us more flexibility than anything else. Okay, now what we will do is, we will understand the MNIST dataset using TensorFlow 1. I am going to run this in the Google Colab notebook. So one thing that you should know is, in Google Colab they use the most recent version of TensorFlow or Keras. So every time what will happen is, this thing will actually be the most recent one, but since we are using, so right now at the time when I am recording the TensorFlow, the most recent TensorFlow version is 2.5 in Colab. So I need to change that and shift that into 1.14. So that is why I have installed TensorFlow 1.14. You can use any version. I am using TensorFlow 1.14. So here the whole thing, it is downloading the whole thing. So this takes some time. So let us look back and understand what we had to do in TensorFlow 1. So in TensorFlow 1 we had the concept of computational graphs. These graphs were used to build our model. So how did these graphs look like? We had nodes and we had edges. Our edges were the data points. They were our edges, and our nodes were the operations. Right? We had the operations like addition, subtraction or whatever, and they were known as ops. So our nodes were ops. Once we have a computational graph, what we will do is run that inside our session. So that is how TensorFlow 1 used to work. Now let us understand this in the case of our MNIST dataset. So this is our neural network structure that we will be using. We have an input layer, we have two hidden layers, and this is followed by an output layer. So how will our structure actually look like? Let us understand. So the one that we will be using is, we will have our input layer, and these will be the number of nodes in the input layer. This will be fully connected to hidden layer 1. In this hidden layer we will be having 256 neurons. Obviously you can select the number of neurons you want. There is no compulsion in that. This is followed by hidden layer 2. This again has 256 neurons, and both of these are followed by then the final output layer. This has approximately 10 neurons. So what do we have? We have here input. Input has 784 neurons. Why 784? Let's get back to what we learnt in the last class. Our MNIST dataset has 28 cross 28 pixels. If we flatten this out, we have one vector which is of 28 cross 28 dimension, that is 784 dimension, right? So we have 784 input neurons, 256 hidden layer 1 neurons, 256 hidden layer 2 neurons, and 10 final output neurons. Why 10 neurons? Because we have 0 to 9. So the thing is, the input number of neurons and the output number of neurons is always fixed depending upon our data set and our output, right? Okay, so that is what we are writing here. Since we are using a multi-layered perceptron, we will have to first flatten the whole thing. So this is a very small description of the MNIST dataset, but since you already know, we have 60,000 training examples, 10,000 testing examples. All the values for the numbers have been centered and normalized to lie between 0 and 1. So the colors actually lie between 0 to 255, but we have normalized it so that it lies between 0 to 1. And they have already been simplified and flattened. Now we will be importing our data set here. We have our data set. We have written 1 hot equal to true. That means the labels will already be in 1 hot encoded format. Since I just downloaded TensorFlow 1.14, so I'm getting all these warnings. If I run this again, I have no more warnings anymore. Then we have our learning rate, number of steps, batch size, display step. Now I am going to make you understand the difference between number of steps and display step. So what here I have done is, this is also one of the terminologies that is used a lot. So the number of steps divided by display steps is basically equal to the number of epochs. That is what this is. These are just fancy terms is all. So you have 500 number of steps and 100 display steps. That means your number of epochs comes down to 5 epochs. So we will be running this for 5 epochs. Then these are the number of neurons in the first hidden layer, number of neurons in the second hidden layer. It is always good to define all your parameters before training, so that it gives more flexibility and you don't have to every time go and find where that particular value is. You can just change it from here. Then number of input size is 784 because 28 into 28, and number of classes is 10 because 0 to 9. If you remember, in one part I mentioned that the data input and the label are both placeholders, or they will be both used as placeholders in the session. So the input and the output are basically used as placeholders because the value keeps changing and we have to feed the value at the time of the session. So that is why this is used. Next we have the weights. We have to define the weights ourselves, obviously, because unlike other neurons and other structures and keras and everything, here we have to do a lot of stuff by hand. Okay, so we have H1, H2, that is the weights for hidden layer 1, hidden layer 2 and the output layer. We have TF dot variable. Now TF dot random dot normal, number of input, number of hidden 1. If you remember what I mentioned when we were doing this, when we had all these inputs and then we had one layer here like that, and all of these were, let's say, fully connected and everything. So we used to get a matrix. The matrix was this number into this number. So what is this? 4 cross 1 2 3 4 5 6. So the weights were of this dimension, right? So here also the same thing is happening. This is number of input comma number of hidden layers 1. So this is basically the weights for this here, this part. Then we will have one weights for here and one for here, the output. Okay, so this is what we are doing. So H1 is a variable function because the values will keep changing. H2 again for the hidden layer, here the dimension will be n hidden 1 and n hidden 2. Now they both will be belonging to normal classes. And output finally number of neurons in the hidden layer 2 comma number of classes. The same way we will have biases, obviously nothing new here. So bias is equal to the number in which this is going, that is the number of neurons in the output. So that is why n hidden 1, n hidden 2 and number of classes. Now that we have defined our weights and biases and we have used two variables for placeholders for the input of data for training, now we will create our model. So this is a basic neural net that I am creating inside a function. We have layer 1. Okay, let us run these one by one first. So we have layer 1, which is basically tf.add into tf.matmul, input multiplied by the weights, addition of the biases. So this is basically, since we cannot use this dense thing anymore, so what this has done is tf.add and inside that we have tf.multiplication matmul. So what is happening is, first we are multiplying the input x here with the weights and then we are adding that with the bias. This was our function, if you remember. This was the y that we were getting. We had to sum all of this and then this was passed into an activation function. So the same way we had the same thing for layer 2 and our output layer, the same manner, but we will be only returning the value of our output layer. So now we are creating our model and saving it inside logits. Then we will define our loss and optimizer. So our loss is tf.reduce.mean softmax entropy. So this is basically, you have our loss is softmax and mean of the softmax. So this is what our basic loss is. So like this is actually, I mean, you have to write everything here, so that is why you are like okay, but it becomes way too much easy when you are doing it with Keras, right? You don't even realize how easy it becomes. Then we have optimizer. Here basic, they already have the Adam optimizer written, so we can just call it like that, tf.train, and optimizer we can add our learning rate. So if you remember what was our learning rate, if you remember the function when back propagating and updating the weights using optimizers, we had w new equal to w old minus eta times of del L by del W. This was for basic gradient descent. If you do not remember, I suggest to go back and understand this very quickly, revise, and then we can continue from that. So I have defined the optimizer here, and now this is for the actual value and corrected value. So this is basically for evaluation of our accuracy. So tf.args.max, the actual output argmax, the actual one, and the one that we are getting from a model logits, right? And once we find that, our accuracy is reduction of the mean of all this. Okay, so this is what this is. Next, the very first thing that I have said always is, whenever you have variables, you need to initialize the variable using this tf.global variable initializer. What this does is, while running the session it stores some space inside which we can change the value of every variable as we keep on updating. Now we have tf.session as says, and here we will be running the init first of all to actually save the value or cache some space for our variables. Now for each step in number of steps plus 1, this is basically just a fancy way of writing, but you understand what this means, right? Then we call for the batch x and batch y. The next batch, what it does is basically, you have a batch of, we had 60,000 data points, right? So if we have 60,000 data points like this, it calls this in batches. So next batch calls the first batch, then it is followed by calling the second batch, then the third batch, and so on. So this is what happens in the next batch. So now we have our batches x and y. We have ses.run. This is where all the training happens, all the computational graph is actually computed. Train op was basically what? Here, this train op was optimizer dot minimize loss op. So our main thing was to minimize this with the help of optimizer, and we connect both the loss and optimizer using the train op. Okay, so we have session.run train op. What will we be feeding into the data? We will be feeding x, which is the batch x, and y, the batch y, which is here, if you remember the two placeholders, right? Okay, so now that is done. For step modulus display step double equal to 0, that is for each epoch, what will happen? We will calculate the loss and accuracy. So loss and accuracy will be calculated, and these are the dictionaries that will be fed. The same thing that we were doing here, we were doing here also. So the reason why here we are just running, we are just back propagating and running the whole thing. Here we are actually calculating the values to print those values, right? And then finally we are printing the values. And that is done. Now that we have done that, you can see the training accuracy, it came to 0.922. However, when we completed the whole thing, our test accuracy was only till 0.83. So what happened is session.run, we did the same thing for testing. So you have to understand with this whole thing, the whole concept of TensorFlow 1 is, even if you are predicting or testing or doing anything, you always have to do this session.run. So inside the session, you have to create a session every time and run it. So that is basically the whole thing about TensorFlow 1. You have to make a computational graph and then you have to run that within a session. So what we understood in this whole segment was basically the use of TF1. So now you might be thinking, okay, so Keras is like way easier to do. This took so many steps and so many lines. Keras was obviously very easy. So I always say people to go and do through Keras if you can. But if there are things that you cannot do with Keras, I would definitely suggest to at least know what happens in TensorFlow 1. So we understood the use of TensorFlow 1 through the use of MNIST dataset, which are basically handwritten digits. So the digits vary between 0 to 9 and our task is to predict the value of each digit, each image, and predict what digit it contains. So that is the whole task of the MNIST dataset. So that's it for today. Thank you and enjoy learning.